What is up, Flutter devs? Welcome to today's Widget Workshop. A Widget Workshop is a relatively brief live coding exercise where I show you how to build a particular widget or visual effect in Flutter. They typically range from 20 minutes to an hour, depending on what we're building. Today, we're going to build a Robinhood-inspired Candlestick stock chart. That's right. Now you're going to know how to build a UI that looks just like the one where you lost all your money. Now, if you're not sure what a candlestick chart is or how to read one, don't worry. I'll explain candlestick charts at the beginning of the workshop. Now, I managed to lose 90% of my net worth researching this workshop, so if you happen to enjoy this video, please be sure to like, subscribe, and to share. Those internet points go a long way to make me feel better about no longer having any money. With that said, let's get into the workshop. Welcome to today's Widget Workshop. Today, we're going to learn how to paint a candlestick stock chart in Flutter. Of course, I'm sure some of you don't really trade many stocks, and if you do, maybe you just look at that kind of traditional line graph, the squiggly up and down that shows you the price action. So maybe you don't really know what a candlestick chart is. Very quickly, I'm going to show you how to read or how to understand a candlestick chart so that you can then go learn how to paint one in Flutter. So let me explain a little bit about how this works. Whenever you're looking at stock, or whenever you're looking at price action, whenever you're looking at changes to the stock price, you're looking within some window of time. And let me represent that window here with some vertical dashed lines that are going to look really terrible because I'm drawing with a mouse and I can barely draw with a pen. So this is doubly bad. We have some window of time here, and this window of time, it could be 10 minutes, it could be half an hour, a day, a week, a month. It doesn't matter. Whatever the window of time is, there's some kind of price change going on. So you're probably used to seeing graphs like this, especially recently with certain pandemics. Anyway, this is the stock movement over time. Again, this could be a 10-minute period. It could be a day. This is the movement that you're used to seeing. But there are 4 numbers in this window of time that are of special interest to traders. And I'm going to call those out here. Let me grab some red. One of these points is called the open. And I'm putting a red squiggly circle over that. That's the open. Open refers to the very first sale price in the window of time. You can also think about it like, hey, the stock market just opened. Of course, that's not the case depending on the window. I mean, there's only one open per day, but you can divide these windows. You can have as many windows as you want. So there can be as many opens as you want, but that's what this point is called. The very first sale price is the open. The very last sale price over here, I'm making another red circle. This is the close. Open price, close price. And then if we look across all of the prices in this window, there is the high, which is right here. This is the highest price in the entire window. And then there's the low right here. This is the lowest price in the entire window of time. These 4 prices, out of all of those prices, these 4 numbers, these are of special significance to traders, and many traders want to see these 4 numbers represented very compactly. So let me draw a horizontal line across each of these places in the graph over here to the right, because we're going to transpose and we're going to create a different kind of graph. By transposing these lines, or these points, we are ignoring all other data in that line graph, and we're going to draw a candlestick. A candlestick chart is just a bunch of candlesticks, and there's one candlestick per window. Here's how we're going to draw that. Let me grab a rectangle here and we'll go with a gray color. Up here we have the high, the highest price in that window. And then down here at the bottom we have the low, the lowest price. I'm going to draw a very thin rectangle from the high to the low, like this. And this is known as the wick. The reason that a candlestick chart is called a candlestick chart is because each item in the chart kind of resembles a candle. A wide wax cylinder with a very thin wick. So this is the wick. The wick goes from the highest price to the lowest price. And then the part that I will just refer to as the candle, but this would be like the wax part of a candle, it sits between the open and the close. So notice that we closed lower than we opened. That means that we lost money on the day. That's a net loss on the stock as opposed to a gain. It's either a gain or a loss. This one's a loss. And whenever you have a loss, that is typically represented in red. So there's the wax part of our candle, or I'll just call that the candle and the other part is the wick. This is one single candlestick from a candlestick chart. A candlestick chart will have many of these. So let's say you take an entire day's worth of trading and you divide it into 10-minute windows. Every one of those 10-minute windows will have one of these candlestick-looking things, and it represents these four numbers: the high, the open and close, and the low. And just to be clear, the open is not always higher than the close. It depends what the price action was. If it's a good day, if it's a gain, the close is higher than the open. But I can only show you one graph here at a time, so we're looking at one that was a loss, went negative. These four numbers are represented by this candle-looking thing, and a bunch of these candle-looking things put together is how we have a candlestick chart. So with that said, we're going to go learn how to paint an entire chart of these candle things coming up. Now that you know what a candlestick chart is, let's jump into this project where we try to paint one. Now you can see over on the right, over in the iOS simulator, we have a layout here that looks very much like your favorite stock trading app. But there's this green box in the center, and that is waiting for us to fill it with a candlestick chart. Now, let me very quickly tell you what's already existing here, because there's quite a bit of groundwork that I've already laid, because this is just a widget workshop and we're only here to paint the candlestick chart. Over here in the simulator, I can tap on these different periods of time: 1 day, 1 week, 1 month, 3 months, 1 year, 5 years. You'll notice that each one is red or it's green. That indicates whether that period of time saw a loss or a gain. So over 1 week, it's red, we actually lost money. But over 1 month, it's green, we gained money. And then up here below the current price, you see the actual dollar and percentage change for that period of time. This is actually pulling from real data. It's not pulling live data, but it's pulling actual stock data. And if we look here in the IDE, I'll give you an example of one such file. So I grabbed a few JSON files from a free online API. This particular one represents a single day, and you can see here the interval is 15 minutes. This is for the Goog symbol, which is the alphabet stock. And down here we have this time series, which is a bunch of those windows of time that I was telling you about. Remember, just a minute or two ago, I was telling you about the high and the low and the open and the close. I have a JSON file here which essentially captures every 15 minutes. It captures these 4 values for every 15 minutes, and that's what we're going to use to actually paint our candlestick chart. Now you'll also notice this reference to volume. What is that? Volume refers to the number of transactions, the number of shares sold on the market in that period of time. So within a 15-minute period, there were, well, this is probably the, I guess that's the close of the market, which is maybe why that number is so high. But that's a pretty high number right there. 94,212 transactions or shares sold, I guess, because actually one person may have sold 1,000 shares because apparently they're rich. 94,212 shares sold in this 15-minute period. And then down here, 54,000 sold, 42, 41. Anyway, there is a list of all of these 15-minute windows throughout the day. And every one of these windows gets its own candlestick in the candlestick chart. Now, I've also written some code here, and I have a stocks_domain file. I've created an enumeration which represents gain and loss. I've explicitly represented the different time frames: a day, week, month, 3 months, 1 year, 5 years. And let's see, most importantly in here, I've created the concept of stock time frame performance. And notice that it's based on a time frame and windows. So the time frame would be like 1 day, and the windows, this time windows, represents all of these individual time windows here in the JSON. So this is how I'm deserializing the JSON into a Dart object that we can then use to paint. So we're not going to go download the files. We're not going to deserialize the JSON ourselves here. This is already done for us. I just wanted to let you know that all of this data, it's real, it's coming from JSON, and I'm already deserializing it here into Dart objects. And we're going to use that data. We're already ready to use it. Again, every one of these items, these time periods that I click on here, it actually provides our widget system with the correct deserialized data for that time period. So it's just waiting for us to get in there and paint it. So that's where we're beginning this exercise right here. This is the actual widget code that we're going to begin with. This right here is our green rectangle. But you're actually going to get more than just a candlestick chart from this widget workshop. We're going to actually paint 2 charts. One will be the candlestick, but the other is going to be a bar chart, which represents all those volume differences, the volume trades for every window, because we want the candlestick chart to take up most of the space. And then at the bottom below the candlestick chart, we want a narrow volume chart. So first, let's divide up. We have 195 pixels that we've allotted to ourselves for this. Let's divide this up into 2 different areas for our 2 different charts. So let's surround this. I'm going to surround it with a column, and we will have 2 containers in this column. And I'll go ahead and put a sized box in between to separate them slightly, just by 5 pixels. And then this top one, this is our candlestick chart. We're going to go 160 pixels for our candlestick chart, and we're just going to go 30 pixels for our volume chart. And let's save that. And you'll notice over here that this kind of black line just appeared. That represents the separator between the 2, and this bottom rectangle is going to become our volume chart, and this larger rectangle up top will become our candlestick chart. So let's go ahead, let's implement this bar chart first, okay? So where we currently have this bottom container, let's change this to a sized box. And as a child, let's introduce a custom paint, because we're not going to try to assemble widgets to create a chart. We're just going to paint the chart. Let's go with an infinite size, which will take up all width, and it will take up all 30 pixels of height. And then it's going to want a painter. And we're going to call this painter Stock Volume Painter. Come down here and declare the Stock Volume Painter extends custom painter. We need to implement 2 methods. We don't care about optimizing right now, so we're going to return true in should repaint, and we'll leave the paint method for just a second, because I'm going to create another object that we're going to use in this process. So we could just look into the stock data and kind of directly turn that stock data into drawing commands. But instead, I'm going to introduce an intermediate step. We're going to take the stock data, then we're going to generate a list of bars, and then we're just going to paint the bars. So it could be one phase. Instead, we're going to do 2 phases. And we're going to do this first because I think this makes it easier for developers to understand what's happening when they read your code. Second, if you ever want to yank out the bar generation code as, let's say, a presenter object, your painting code here will be ready to have that extracted. So let me show you what I mean. We're just going to create a class called bar. And we're going to have a width, we're going to have a height, we're going to have a center X, and we're going to have a paint object. Now, maybe if you pulled it out into a presenter, instead of a paint object, you would just use a color so you don't import the painting system. But for here, given that we're going to create the bars and paint the bars in the same place, for right now, I think it's fine that we go with a paint object. I've generated a constructor for each of these properties, and I'm going to point out that every one of these is required. There's no bar unless we have all of these. Now imagine that we had a list of these bar objects and every one had a center position, a width, a height, and a paint to paint it with. Then it would be very, very easy for us to draw the bars, right? So that's exactly how we're going to approach this. We're going to create all the bars and then we're going to paint all the bars. So now let's come up here into our custom painter, and let's initialize it with some things that we know we're going to need. We know that we're going to need stock time frame performance. This is the data about what the stock does over time, and we'll call that stock data. We're also going to need what I'm going to call a gain paint. That's a green paint because gains we're going to represent as green, and then a loss paint. That's going to be red because we're going to paint our losses in red. Then we're going to have a stock volume painter constructor. It's going to take in stock data, and then we're going to initialize our paints. So gain paint is a paint where the color is green. Now for the volume chart, I don't want it to visually get in the way of the candlestick chart. And to help with that, not only are we going to use the color green, we're going to reduce the opacity to 50%. So this bar chart is visible if you want to see it, but the intensity of the colors is not going to conflict with the candlestick chart above it. Now we'll create our loss paint, which is red with an opacity of 50%. And now we should be ready to paint, or at least to generate the bars and then paint them. Of course, up here in the stock volume painter, we need to pass in the stock data. Well, where does that come from? Well, the way I've constructed this widget workshop, we're actually in a function that's invoked by my other code, and we are literally given the stock data to paint. So we don't have to go do any other processing or access stuff in weird places. We are given the stock data so we can go right into the painting process. So down here in the stock volume painter, we're going to provide the stock data in the stock data property. Okay. Now we need to do something about this paint method. First, it is possible that the stock data is null because whether you're reading it from a file or whether you're loading it from a web service, there's going to be some period of time where it's not available. So we're going to come in here and we're going to say, look, if stock data is null, then we're just going to return. But otherwise, we need to generate the bars and we need to paint the bars. These are the 2 steps to get us to our goal for this initial bar chart. We'd like some method, let's say called generate bars. And we're going to pass in the size because it's likely that to generate the bars, we're going to want to know what our available painting dimensions are. What's the total width available to us? what's the total height available to us. So we want to generate bars, and then down here we want to paint them. Let's declare this generate bars method. When it comes to generating bars, we need to determine, again, the width, the height, and the center position for every bar in the bar chart. Every bar should be horizontally centered within an equal division of the available space. So we're going to start by calculating what we will call pixels per time window. So remember that we're representing, for example, every 15-minute period within a trading day. So every one of those 15-minute windows needs to take up a certain equal amount of space available to us. So we're going to take the available space, we're going to take the width, and we're going to divide it by stockdata.timewindows.length, and we're going to add 1 to it. The reason we're adding 1 to it is because we don't want any of our bars to literally touch the edge of the screen. So we're adding one more window. We're adding one more window to the total number of windows so that our first bar is off the left side of the screen and our last bar is off the right side of the screen. Now, not only do we need to take into consideration the available horizontal space, but we need to determine how tall to make every one of our bars. Now, how do we decide how tall to make our bars? Well, our primary constraint here is that we don't want the tallest bar to exceed our available height. So what we're going to do is normalize all the heights. We're going to make our tallest bar as tall as all of the available space, and every other bar is going to be a fraction of that. And here's how we do that. We're going to calculate the pixels per stock order. Remember that what we are charting here is volume trades. We're charting the number of orders. So every single one of those orders takes up a certain number of pixels. Now, in reality, it's a tiny, tiny fraction of pixels because there might be 10,000 orders in this window. So then like 0.0001 pixels per order or something is what we end up with. But we'll take available space, we'll grab the height, and we'll divide it by the max window volume. This is a property that I have already calculated for us because I knew that we would need it. What I did is I went through all the different volumes and I just logged the largest volume in the entire window, or really in the entire trading period at this point. So we grab that largest number, we divide the height by the largest number, and now we have the pixels per stock order, and we can finally get into actually generating this list of bars. We're going to iterate through every time window in our stock data. So if we're looking at a single day, this is going through every 15-minute time window in that day. We're going to grab that time window, and now we are going to actually calculate how that bar should look. The width, I'm just going to make that constant. We're going to go with 3 pixels for the width. The height is we're going to take the volume for this particular window. So this is like, let's say that 5,000 trades occurred in 15 minutes. This number is 5,000. That's what window.volume is. And we're going to multiply it by pixels per stock order, which then gives us the number of pixels that this bar should take up. All right. And then we want the center position. We're going to take I plus 1. Now, why I plus 1? Well, because if we took I, that means our first value would be 0. But 0 would actually have us painting on the edge of the screen. We don't want that. So we're going to jump one space ahead. We're going to take I plus 1, and we're going to multiply by pixels per time window. This tells us the available horizontal space that we have for this bar. And then finally, we need to choose the paint, gain or loss. Well, we're going to say window, is it a gain? If it's a gain, we're going to go with the gain paint. If it's a loss, we're going to go with the loss paint. And now we've configured our bar, width, height, center, paint. We've added it to the list. And finally, we just need to return the bars. And we've now generated all the bars, at least kind of like view models for all the bars in our bar chart. So we can come back up here, and now our first step is done. We have generated the bars. Now it's time to paint the bars. Because like all the hard work was actually just generating the bars, painting them is very easy. We'll just say for each bar in bars, we're going to take our canvas and we're going to draw a rectangle because our bars are rectangles. We're going to say rectangle from left, top, width, and height. Let's just get this all spaced out nicely. Our paint, that's really easy. That's just bar.paint. Our left position, now in our bar, we didn't store left position, we stored center. So we take the center X and we subtract bar.width divided by 2. Got to divide it in half because this is our left position. It's only half. Then the top, now this is one area where you got to think for a second. We typically look at charts as if the origin is in the bottom left, as in the higher up you go, the higher the Y value. That's how we think about charts. That's how we typically calculate things. But the painting origin in Flutter and most other UI toolkits is actually the upper left, not the lower left, the upper left. So when you're painting, as numbers get larger, they go down, not up. We need to essentially go from our chart coordinate space to the painting coordinate space. And it's very easy to do, but here's how you do it. We take the height. Instead of just, see, you might be tempted to just do something like maybe bar.height. You might even be tempted to do something like minus bar.height. But these approaches don't recognize that we change coordinate systems. So instead, we start with all available height. This pushes us all the way to the bottom of our available height. And then we subtract bar.height. We push all the way down, and then we subtract the height of our bar. That's how we get into the right position to paint this thing. How wide is the bar? It's the width. How tall is the bar? It's the height. So for every bar, we draw a rectangle on our canvas based on the bar's properties and the available paint. And let's save that. And check that out. Right there at the bottom of the chart, we have our bars spaced evenly, colored correctly, colored based on the actual gain and loss data. And not only does that work for one day, but because of the code that I've already written for us, if we click 1 week, we get the 1 week volume movement. 1 month, 3 months, 1 year, 5 years. Okay. So that's getting us started. We've got the volume chart, and now we finally get to the candlestick chart, the reason you're here, the thing you've been waiting for. So we'll jump and get into that next. We've got our volume bar chart, and now it's time to paint the candlestick chart. And we're going to follow a pattern that's very similar to the one we just did for our bar chart. Remember, for our bar chart, we introduced a custom painter and we introduced a bar to represent every bar in the bar chart. Well, now we're going to introduce another custom painter, and we're going to introduce the concept of a candlestick, which represents every candlestick in our chart. So let's come up here to where we have our column with our 2 charts, and we're going to take this custom paint and we're just going to copy that right on up to the top part. But instead of a stock volume painter, we're going to want the concept of a stock candlestick painter. Doesn't exist yet, but we'll create it. And we're going to pass in the stock data just like we did with the other painter. So let's go create that stock candlestick painter. Once again, we need to implement the two appropriate methods. We don't care about optimizations, so we'll always repaint. And we do need to figure out painting. We'll do that in a minute. But we also want to introduce the concept of a candlestick. A candlestick, as we've discussed, includes the drawing of a wick and the drawing of the kind of candle itself. We need to capture enough information in this object to be able to easily paint each one of the candlesticks. So we're going to want, for example, the wick high Y position, the wick low Y position, the candle high Y, the candle low Y. Of course, both the wick and the candle share the same center X, and we need to know what paint we're using for the candle. Now, the reason that I'm only including the paint for the candle is because the wick is always painted the same way. It wouldn't hurt to include a paint for that, but again, in this kind of simplistic project where we're not really breaking things down, it doesn't really matter. So that's an adjustment you can make in your code if you'd like. Now let's generate the constructor for one of these candlesticks. Going to convert these all to named parameters, and we're going to space them out. And once again, we're going to make it clear that every one of these is required. Every candlestick needs every one of these properties. With candlestick created as, again, a kind of view model, we're going to come back up and consider our custom painter here. So first, we need to decide what properties do we need in our stock candlestick painter to accomplish painting. Well, we know that once again, we're going to need the stock time frame performance, which we will again just refer to as stock data. This time we need 3 paints instead of 2. We need the wick paint. We need the gain paint. This one's the same as the bar chart. And loss paint, which is also the same as the bar chart. Now I'm also going to hard code a wick width, which is just going to be 1 pixel wide, and a candle width, which is going to be 3 pixels wide, which matches our volume width. We could have inlined these in the paint calls themselves. Since there's 2 numbers this time, I'm just calling them out up here as constants. But let's go ahead and assign the values that we need for our stock data and our paints. We'll declare the stock candlestick painter constructor. We will take in stock data, and now we need to initialize our paints in our initializer list. Wick paint is a paint where the color is, in this case, let's go with, well, we just go with a gray. We have an official gray. Let's go with the official gray color. And then the gain paint is a paint where the color is green. The loss paint is a paint where the color is red. And notice this time that we don't, let's see, what's it complaining about here? Oh, not equals equals, just 1 equals. Notice that we're not lowering the opacity. We want full vibrance in our candlestick chart because that's the primary goal of what we're trying to communicate to the user here. And now up here, of course, we're already passing in the stock data, so we're good there. Now, once again, in the paint method, if the stock data is null, we're going to paint nothing. We're just going to return. But otherwise, once again, we need to generate the candlesticks and we need to paint the candlesticks. Okay? We want a list of candlesticks. And to get the list, we want to generate candlesticks, and we're going to pass in size again so we know what our available space is. We'll declare a method called generate candlesticks. We will take in a size, which is the available space, and now we need to actually generate these candlesticks. Very similar to generating the bars, the first thing that we're going to do is calculate pixels per window. And in fact, this calculation is exactly the same because we are subdividing all of our available space by the number of windows. Now, once again, we add 1. Why are we adding 1? It's so that none of our candlesticks are actually squeezed up against the side of the screen. We're introducing an additional window. So that's our horizontal space available for each candlestick. Then we have the pixels per dollar. We're working with dollars now. The bar chart at the bottom was dealing with transaction counts or shares, number of shares, but now we're talking money. We're talking pixels per dollar. So we're going to take the available space, we're going to grab its height, and we're going to divide it by the highest value of, remember that stock, the price moves up and down like this, and there's a maximum height, not just for the window. I mean, every 15 minutes, there's a high and a low, but also for the entire day, there's a high and there's a low. We're going to allot vertical space based on the very highest value for the day and the very lowest value for the day so that our graph never exceeds the available height. Again, this is a process known as normalizing. We are normalizing our data to the available painting space. So we're going to take the high and we're going to subtract the low. And remember, this is for the entire time frame, the entire day, the entire week, the entire month. And with these two properties, we can now go through and generate each of our candlesticks. First, we're going to declare a list of candlesticks. Then we're going to go from 0 to stock data, time windows, length. And we're going to grab the stock time window. Because remember, each one of these candlesticks represents a single window of time. We are now going to add a new candlestick to our list. And once again, let's get this all spaced out and then we'll figure out what these values should be. What's the center position for our candlestick? It's going to be I plus 1 times the pixels per window. This is the exact same center calculation that we used for each one of the bars in our volume chart. Now remember, the wick is the tallest part. It goes from the high to the low. The candle either goes from open to close or close to open. So for the wick high Y, we will take the high value. We will take the high value for this window, not the whole time frame, just for this, like, let's say 15-minute period. We're going to grab the high and we're going to subtract the global low. So remember, we are guaranteed that the lowest number in the entire set of stock windows must be lower than any of the highs. So this is always going to be a positive number. And we're going to multiply it by pixels per dollar. And this again is achieving our normalization. This is taking our wick Y position and ensuring that it's in the appropriate position within our vertical space. The low is going to look very similar. We're going to take the low for this window and we're going to subtract the global low from it, and we're going to multiply by pixels per dollar. Now we need to calculate the candle. We're going to take the open price, and we're going to, again, subtract the global low and multiply by pixels per dollar. And then for the low, we're going to take the close We're going to do the same thing. Now, this actually isn't necessarily what these... So the open is not necessarily the high, and the close is not necessarily the low. This should the terminology here should probably be changed, but we will deal with this fact in our painting. So just keep in mind that these two things do not necessarily correspond. Either the high should be the open, the low should be closed, or the high should be closed and the low should be open. It's not going to make a difference by the time we're done with this, but that is probably a minor confusion point that I should resolve at some point. Anyways, for our candle paint, we're again going to ask, is this a gain? Did we gain in this window? And if so, we're going to use the gain paint. Otherwise, we're going to use the loss paint. And then again, at the end, we are going to return all of our candlesticks. That now completes the step of generating the candlesticks. In terms of painting, we're going to start by painting all the wicks, and then we'll come back and paint the candles. So under here, under paint candlesticks, we're going to say for candlestick, in candlesticks, we are going to say canvas, draw a rectangle, rectangle from left top, right bottom. Let's get our spacing. For paint, that's the easiest part. We just, we use the wick paint for this one, the global wick paint. And now we need to calculate the left, top, the right, and the bottom. So what is the left? The left is calculated the exact same way as it was for the individual bars. We're going to get the center X. We're going to subtract the wick width divided by 2, 1/2 the wick width. We're going to ignore the top for a second, and we're going to calculate the right. The right is the center, this time plus instead of minus, plus the wick width divided by 2. And then down here we have the bottom. So we need to calculate the top and the bottom. Now, once again, we need to go from our mental model of a chart to the mental model of the coordinate space for painting. So we begin, for the Y value, we begin with size dot height. And then we subtract the candlestick wick high Y. The high Y, to make it higher, if it's high, it's going to be the top, right? So when we're painting left top, right bottom, the top is going to correspond to the larger of the two wick Y values, which is why we use it here, which means that the bottom is all available space minus candlestick wick low Y. And with this, again, we are just painting the wick. When I save this, we should see a bunch of thin gray lines appear over here. Saving in 3, 2, 1. And there they are. Sure enough, those are our wicks. And if we click on different time frames, notice that the wicks change because they are based on real data, and that data is changing in these different time periods. And remember, I talked about normalizing. Notice that none of these wicks exceed the available vertical space. That's because the height of every wick depends on both the available height as well as the lowest price and the highest price in that entire time frame. And now for the final step, it is time to paint the candle. It's a very similar process. Canvas, draw a rectangle, rectangle from left top, right bottom. The paint this time is candlestick.candle paint because remember, it's green for gain, red for loss. Let's save that to get some vertical space here. Now, what is our left, top, right, and bottom? Well, the left and right are almost exactly the same as the wick. We just need to adjust the width value. Instead of the wick width, we're going to go with candle width. And now we just need the top and bottom. And the top and bottom, again, are going to be almost identical to what we've already calculated. Again, I'll copy this line down. It's size.height, but instead of subtracting wick high Y, we subtract candle high Y. And then almost the same thing for the bottom, which is low Y. Now, if you're looking carefully at this, you might notice that actually the top and the bottom maybe should be inverted. What it is that it actually appears like this rectangle, either the rectangle itself or the painting call, takes this top and this bottom and checks to see which one is less. Or in some fashion, it uses a transformation so that it doesn't care. Because when we run this, it's going to paint what we expect it to paint, even when these two values are inverted. Because this, anytime that we have a loss, this math is correct. But anytime that we have a gain, technically we should reverse these because the close will be higher than the open. Again, the painting system apparently can figure this out. You should do better in your codes that your developers don't get confused, but we're going to be just fine here in our case. So again, when I save this, we should see the candle part of our candlesticks painted. So we're going to save in 3, 2, 1, save. And there they are. Check that out. Reds and greens. Some of these, you can barely see the candle, and that's because the open and close were almost identical. But there we have our candlesticks all the way through 1 day of movement and 1 week of movement, 1 month of movement, 3 months, 1 year, and 5 years. 5 years is looking pretty good. And that is how you can paint a candlestick chart in Flutter. Of course, if you were to productionize this, you'd probably offer all sorts of controls for the color of the wick, the color of the candle, the color for the volumes, how wide should each of these things be, what should the background color be. You might even animate between these different charts. There are an infinite number of complications that you can add if you want to, but fundamentally, this is how you paint a candlestick chart. So that brings us to the end of this widget workshop. I hope you learned something, and I'll see you in the next one.